Very good morning everyone and welcome back to the IFAS students. So today's topic is going to be Picard's theorem. बहुत important topic है. So how one can solve problems on Picard's theorem? Before that we need to understand the statement, have the clarity about this theorem. So what is Picard's theorem? We'll try to understand in today's class. So let me know in the comment section all of you are ready. Everybody is ready for today's class. To share this session with all your friends first of all, then we'll start today's class. Just type ready whenever you are ready. Make sure you are ready with the pen and paper because we are going to do a lot of problems. Okay, you will get some time to solve the questions as well. Akanksha are with us. Good morning, Akanksha. All of you are ready. Just share the session with all your friends before we start today's class, and let's see who is able to solve the questions. First thing you have to do, student, do share this session with all your friends first. This is going to be the 5th session in this series, and we are at the point where we are going to discuss Picard's theorem. This is a very important theorem, and we'll see how to solve the questions. Everybody is ready. Good morning everyone. So let's begin with the statement. So what we are going to do in today's class, Picard's theorem and questions or problem based on the Picard's theorem. Let's start with the statement. Okay, suppose we have a non-constant, an entire function. Okay, then it omits at most one. Now what do you mean by at most one? What do you mean by at most one? X is at most 1 means x is greater or equal 1. Okay, x cannot exceed 1. At most 1 means cannot exceed 1. So either it can be 1 or 0. These are the two possibilities. Okay, because we are counting the points, so it has to be either 1 or 0. So at most function can skip one value. For example, if I give you function, let's say sin z, what is the range of sin z? What is f of c? I will tell you sin c is c, means sin does not skip any point, so it skips 0 points. Okay, if I give you, let's say cos z, again f of c is c, it also doesn't skip any point. If I give you exponential e to the power z, it does skip 1 point, namely 0. F of c is simply c minus 0. So it has permission to skip, to omit at most 1 point, either 1 or none. Okay, it can skip either 1 or none. Hopefully all of you understood. Similarly, if I talk about hyperbolic functions, so what is the range of hyperbolic functions? Cos hyperbolic. Can anybody tell me the range of hyperbolic functions? What could be the range? Let me know in the comment section. C, why C? Look at this. Range of sine hyperbolic function is C. Why? Because we know that sine hyperbolic C z, this is essentially e to the power z minus e to the power minus z by 2y. Okay, this e raised to z attains every value except 0. This e raised to minus z again except every value except 0. Now can this combination achieve 0? Definitely yes. See, so e to the power z minus e to the power minus z by 2, this can be 0 if and only if e to the power z, e to the power minus z, this is 1. If I cross multiply, students, what will happen? This is e to the power 2z minus 1 upon e to the power z is 0. This is e to the power 2z minus 1 equals 0. This is e to the power 2z is 1, which is essentially even multiple of pi I, and 2z has to be 2n pi I. 2 to get cancelled, z equals to, whenever our z is even that is the integral multiple of pi I, will get 0. So 0 is also getting achieved here. In previous case we have seen 0 was not getting achieved. E to the power z achieved everything in C except 0, and this combination together achieve 0 at this point. That means sine hyperbolic C achieve everything in the complex field. Okay, there is nothing to achieve more. Everything is captured by the range. Let me know in the comment section all of you understood this. This is very important to see. So everybody understood. Similarly, we can have cos hyperbolic C equals. So you will see range for this is again C. Now I'm giving you one more example. Suppose if I give you fz equal to e to the power z plus 1, then what would be the range? इसका रेंज क्या हो सकता है? ट्राई करिए and let me know the answer in the comment section. Try this one. What is the range of this? First of all, this is entire, this is non-constant, then range would be what? Which value is cannot achieved? Everybody understood what would be the range? I've given you 2 minutes to think about this problem. Because see, whenever we have entire functions, it is very important to identify the range, because the range will tell us whether the range function have a dense image or not. Okay, whether the image set has a connected image or not, compact image or not. Okay, so what would be the range? So Ashwini is saying range would be C. Okay, anybody else? Pooja, Akanksha, what would be the range? Afreen, क्या होगा हमारा रेंज? इसका रेंज क्या हो सकता है? देखिए, क्या ये फंक्शन 0 ले सकता है कभी? e की पावर z, यस ले सकता है. -1 कब आता है? ऑड मल्टीपल ऑफ पाई आई पे. तो -1 कब आएगा? z जब ऑड मल्टीपल ऑफ पाई लेते हैं. तब -1 भी आ जाएगा, मतलब 0 तो अटेन हो रहा है। क्या ये फंक्शन बच्चों कभी 1 लेगा? e⁻z+1 कभी 1 हो सकता है? नो, ये 1 1 कैंसिल होगा, हमें मिल जाएगा e⁻z0। ये कभी नहीं पॉसिबल है, इसलिए e⁻z+1 1 कभी नहीं लेगा। तो इसका रेंज आएगा C-1। अंडरस्टूड? बाकी सब वैल्यू ले सकता है, 0 भी लेगा, -1 भी लेगा, सिर्फ 0 को 1 को छोड़कर ये कोई भी वैल्यू अचीव नहीं करेगा। एवरीबडी अंडरस्टूड? तो इसीलिए बहुत इंपॉर्टेंट बन जाता है पिकार्ड्स थ्योरम, ठीक है। इट विल हेल्प अस टू आइडेंटिफाई द फंक्शंस। तो ज़्यादा से ज़्यादा एक इमेज में क्या हो रहा है, एक पॉइंट स्किप हो रहा है। तो e⁻z-i का इमेज क्या होगा? व्हाट इज f(c)? एवरीबडी अंडरस्टूड? 1 कैसे गायब हो गया रेंज से? फटाफट बताना है बच्चों। यस, पावर ऑड है ना, इसलिए -1 आता है। e⁻, ऑड मल्टीपल ऑफ पाई क्या हमेशा -1 आता है। फॉर एग्जाम्पल e⁻πi, e⁻3πi, e⁻7πi, ये -1 होता है, ठीक है। चलो आपको बताना है अभी f(z) इक्वल टू e⁻z-i, इसकी इमेज क्या होगी, रेंज क्या होगी? ट्राई करिए। हेलो, वेरी गुड अश्विनी। C-i उसका माइनस आएगा ये, अंडरस्टूड? तो C माइनस है बिकॉज e⁻z-i कभी -i नहीं होगा, बिकॉज ये कैंसिल हो गए, फिर से e⁻z 0 मिलेगा, विच इज़ कैनॉट बी पॉसिबल। सो दिस इज कैनॉट बी पॉसिबल। तो इस तरीके से आप रेंज निकाल सकते हो। एक और तरीका है पिकार्ड्स थ्योरम को लिखने का, अगर कोई फंक्शन ओमिट कर रहा है 2 और मोर वैल्यूज, ठीक है, 2 और मोर वैल्यूज, देन इट बिकम कांस्टेंट। अगर कोई फंक्शन 2 या 2 से ज़्यादा वैल्यू को स्किप कर रहा है तो फंक्शन हमेशा कांस्टेंट होता है। एवरीबडी अंडरस्टूड? यस और नो? कोई फंक्शन अगर 2 या 2 से ज़्यादा वैल्यू छोड़ रहा है रेंज से तो फंक्शन और कोई नहीं है, तो कांस्टेंट है। एवरीबडी अंडरस्टूड? So this is what our Picard's theorem says, and let's see a few problem based on the Picard's theorem. You have one question on the screen. A non-constant entire function has at least one zero, cannot have finite number of real zeros, cannot have countable number of zeros, cannot have uncountable number of zeros. Very good. होपफुली आप सभी को रेंज निकालना आया होगा ऑलरेडी स्टूडेंट्स, बहुत बढ़िया। सो यू कैन स्टार्ट सॉल्विंग द क्वेश्चन, योर टाइम स्टार्ट्स नाउ। दिस theorem, this problem is based on the Picard's theorem, and try to identify the correct answer. Do it. Afreen, Ajit, Akanksha, Pooja, everybody start doing the problem. What could be the right answer? So here you have a poll, you can answer. non-constant entire function has at least one zero, कम से कम एक जीरो होगा, क्या ये ट्रू है? How many zeros this function has? This is non-constant entire. And how many zeros this function has? No zeros. It has no zeros. Can we discard option number A with this? So like this we have to solve all possible questions. So almost 70% students has answered it incorrectly. So at least we cannot say, at most we can say. So this is incorrect. Understood? Ashwini, Afreen, Ajit, Pooja. This is incorrect. You can take a to the power z as well. This is general function, a is positive. This also non-constant entire and carries no zeros. Let me know in the comment section. Okay, try to do the other options and let me know in the comment section. If you think some options, if you feel some options are incorrect, try to produce examples. Try to produce counter examples to discard options. This is a very interesting question. Do this. What do you think would be the correct response to this? Picard's theorem and identity theorem, what is the difference? So let's see. This is Picard's and this is identity. So what is the statement? Every non-constant entire function can skip at most one point in range. So in range it has permission to skip at most one point. What is identity theorem? Statement: if f is analytic on a domain D such that zeros of f has limit point, or we can say zeros of f limit point intersection D is non-empty, then f is constant. So this is applicable for entire function and this is applicable for any analytic function on domain. So it is must that function is defined on C. So the f is defined on C. Here f is defined on domain. Here we don't need to find limit points, okay, but here we need to find limit points. So here we need to find range, and here we need to find a limit point of zeros. Here conclusion is that if it skip more than 1 point, function become constant. Fz is constant if a range of f skip more than 1 point, for example 2 points, 3 points, and here function becomes again constant if limit point belongs to domain. So these are the fundamental difference. Everybody understood Picards and identity. China. All right. So what about the question? Cannot have finite number of zeros, real zeros. Incorrect. Fz take z minus 1. This is a complex function, non-constant है, entire है, and it has a zeros. How much? Finite number of real zeros. Real zeros. So with this we can discard B as well. What is C? What about C? Cannot have countable number of zeros in C. Is it true? Can you produce Fz which is non-constant and has countable number of zeros? What about C? Any example? So here we have taken counter example z minus 1. 1 upon sin z ले सकते हैं क्या? No, we cannot take because we need an entire function. 1 upon sin z is not entire, na? 1 upon sin z is not entire. We need zeros. So why not take sin z itself? You can take sin z or sin pi z. Okay. So what happens to sin pi z? Non-constant है, entire भी है, and how many zeros it has? If I calculate the zeros, sin pi z is 0. If and only if pi z is n pi, pi cancel. So every integer is a root. So zf is n for every n belongs to integer. These are countable infinite integer, and this will work. So function cannot have countable number of zero. This is incorrect. Cannot have uncountable number of zeros. Is it true? Cannot have uncountable number of zeros. What will happen? Now see, we have discarded all three options. So obviously fourth is going to be true, but why fourth is going to be true? Let's see. So let Fz be non-constant, given Fz be non-constant and entire, and option is saying cannot have uncountable number of zeros. Suppose possible Fz has uncountable number of zeros, uncountable number of zeros. So what will happen if it carries uncountable number of zeros, students? What would happen if it carries uncountable number of zeros? So we can say that z of f has a limit point in domain, because every uncountable function carries limit point. So definitely it has to be a part of C. So by identity, we can say identity theorem, f of z is constant, which is contradiction, a contradiction, So our assumption was wrong. So f of z cannot have uncountable number of zeros. Therefore, fz cannot have uncountable numbers of zeros. Everybody understood why D option is correct? It cannot have uncountable number of zeros. Otherwise, function will become constant. Yes or no? Let me know in the comment section. Okay, let's try to do the next one. Question number second. F is a non-constant entire function E with the image set of F. Then what would be E? Whether it is open, whether intersection is empty, E intersection are non-empty, E is bounded or not. So try this. This is very interesting question again. Everybody try this one. E is open set. You see F is non-constant and entire we have given. Okay. So can we use the open mapping theorem here? Can we use open mapping theorem? Yes or no? So let's see. So if I talk about the range, f of c is essentially the range. What would be the possibilities? Non-constant entire function can skip at most one point. So range can be either c or c minus any single point alpha. It cannot be any other than this because non-constant है. ठीक है? So in both the cases E अगर C है तो भी open हो जाएगा. Okay? E अगर C minus alpha है तो भी open होगा. In both the cases we are finding that range is open. This is open. This is a complement of closed set which is again open. So I can say range is open. E is open set. Or we can also use the open mapping theorem. Okay, non-constant analytic function, image of open set is open. So C is open, f of C will be also open. So implies E is open. So E is always an open set. Okay. Now we know that in both the cases E is open and these are the dense set. Also note that E closure is equals to C. That means E is a dense in C. And by the dense definition of dense set, can I say every open set will intersect with every open set U in C intersect with E, that is E intersection with any open set will be always non-empty. So in particularly I can take the unit disk, take U equals to open disk D, then E intersection with this D will be also non-empty. So this is incorrect. Next, E intersection R is non-empty. Now R is also again open set. So can I say E intersection R is again non-empty? Instead of E you can take R now. E is bounded set. Can you say E is bounded? Can you say that E is a bounded set? No, this is unbounded, this is unbounded. So implies this is incorrect. So A and C will be the correct options. Understood? A and C will be the right answers. Okay. Next question I have for you on the screen. Which of the following statements need not be true? If f is entire, can you say that f of c is always open set? If f is non-constant entire function, f of c is always closed. If f is non-constant entire, f of c always dense. If f is non-constant entire, f of c always c minus alpha for some alpha. Okay. So write down this answer for this question. Then I will explain Casorati Weirstrass theorem as well. So फटाफट note करिए. Try to answer this question first. नीड नॉट टू बी ट्रू बोला मतलब फॉल्स ढूंढने हैं. ठीक है. So which of the statement is false? Is it true? If f is entire, can you guarantee that range is always open set? No. Take any constant function f of z equal to c. The range would be, range of f means f of c, which is singleton c, and this is not always open, this is closed set. Okay, this is a closed set. You can take zero map. So this is singleton 0. Singleton set are always closed. So first is incorrect. Okay, so what is the problem? Problem is that function is not given non-constant. If it is non-constant and entire, then we can say range is always open. Okay, but open mapping theorem cannot be applicable here. So this is false and we are interested in false only. So first is not true. Second, if f is non-constant entire, can you say f of c always closed? Incorrect. You can take f of z equals to simply sin z. This is non-constant entire, and we have seen f of c is c. Okay, and clearly this is an open set. Okay, so we can say sin z, or even you can take e to the power z. Okay, this will be the always appropriate function because c is open as well as closed. Okay, so this will not work. So f of c would be what? Range would be c minus singleton 0, and we know that this is a closed set, so range is open, and this range is open, cannot be closed. With this we can discard. So non-constant null function is always called, this is false. This will be also false option. F is non-constant entire function, then f of c is always dense. Yes, this is correct. This is true, because if f is non-constant and entire, range will be always c or c minus singleton alpha. This is always dense. Always dense. If f is constant, then it cannot be dense. So this is very important word, non-constant. Okay, so the third statement is correct or true. If f is fourth option, if f is non-constant entire function, then f of c always c minus alpha. No, need not to be true. Take f of z equals sin z, then f of c is entire complex plane. So this is true. This is false. So answers are A, B and D. Everybody understood? A, B, D are the answers. Let me know in the comment section. Chaliye, let me know in the comment section. Everybody understood this problem? This was a very interesting problem. Hopefully all of you understood this properly. Shall we go ahead? Okay, now let's answer the Ashwini's doubt. ये नहीं समझा, ठीक है. So देखिए, what was the open mapping theorem? Open mapping theory says every non-constant analytic function image of open set is open. D is open implies f of D is open. So this is non-constant word is absent in the first statement. Okay, so if it has a non-constant word in the statement, then it would be it would have been true, but we have not given non-constant word here. Okay, so we can take constant function. So range is not closed, sorry, range is not open. So that's why first option is false. Understood? So now let's try to understand Casorati Weirstrass. Casorati Weirstrass theorem. So what this theorem says, in the neighborhood of isolated essential singularity, fz assumes every value in a range, or we can say f of this deleted neighborhood has a limit point C. This is our Casorati Weirstrass theorem. So what it's saying, the range become dense. F of this disk except 0, limit point is C, or we can say closure is equal to C. So what is happening here? For example, if I take e to the power 1 by z, this is again non-constant and it has a isolated essential singularity, at z equal to 0, fz has isolated essential singularity. So what will happen to the neighborhood, deleted neighborhood of unit disk? If I take deleted neighborhood, let's select this. This is 1. So what is this disk? D is all z such that 0 less than mod z less than, let's say, 1. Then f of d would be what? F of d closure is entire complete. If I take closure of this, it will cover all complex plane C. Okay, this small disk will cover everything. Even if you take the smaller radius, if I take 0.1, still in this deleted neighborhood it will achieve every complex plane in the range. Everybody understood? Yes or no? For example, note this carefully. What is this? 0 less than mod z less than 0.1. What is the image of this? This is e to the power 0 less than mod z less than 0.1. We know that exponential takes every value except 0. So this is actually c minus 0. But what would be the closure? If I take closure, it would be entire complex plane C. It means what? In closure, the function skip no points. Okay, even 0 is also getting achieved. In the closure, it will take every single value in the complex plane. Hopefully all of you understood. Let me know in the comment section. All right. Next we have Mobius transformation. So what is Mobius transformation? A transformation of the form omega equal az plus b upon cz plus d. So such transformation are called as a Mobius transformation. Now condition is that this coefficient determinant a, b, c, d, this determinant should be non-zero. That means ad minus bc should be non-zero. This is what I have written here. Okay, this coefficient determinant should be non-zero. Then only we can call this map to be a Mobius transformation. For example, if I give you this, can you say this map is a Mobius transformation? Can you say this map is a Mobius transformation? Coefficient determinant is 4 minus 2 minus 2 1. So this is 4 minus 4 0. So this cannot be a Mobius transformation. Okay, so it's very important that coefficient determinant has to be non-zero. Let me know in the comment section. Understood? Yes or no? Next we have fixed point. How to find fixed points of the bilinear transformation? Okay, for example, if I give you the map y equal to fx in R, so how do we find fixed point? You take another map y equal to x, just take intersecting points, you will get the fixed point. Okay, so for example, this is our R2 plane, this is the curve y equal to x. I'm talking in a real. Okay, and this is the line y equal to x. So whichever point intersect with the curve y equal to fx, that is nothing but a fixed point. This is called as a fixed point. But in complex, we do not have freedom to actually construct the functions. So in this case, how one can find fixed points? Okay, there is no scope of finding the graph of the curve in the complex plane. So how one can actually find the fixed points? So for this, we have to use the same definition, f of z equals to z. Okay, just equate the image with the points and try to get the fixed points. Okay, so the point which coincide with the transformation fz are called the fixed points. Okay students, for example, these are the few maps. Try to find the fixed points. Okay, your time starts now. Try to solve both the questions and let me know the fixed points. क्या आंसर आया? 0.3 सेकेंड करिए. पहला तो आसान है, ओमेगा z अपॉन z माइनस 2. फर्स्ट थिंग वी नीड टू टेक फिक्स पॉइंट एफ z इक्वल्स टू z. एफ z इज z अपॉन z माइनस 2 इक्वल्स z. If I cross multiply, this is z square minus 2z. This is z square minus 3z equals 0. This will go to the right hand side, will become negative. So we can take z common out. So these are the fixed points. Okay students. Next, omega equals z minus 1 z plus 1. Okay, so what are the fixed point for this? So consider Okay, z minus 1 upon z plus 1 equals z. So this is z minus 1, z square plus z. This we can cancel out. So z square is minus 1. So z has to be plus or minus I. So these are the fixed points of the bilinear transformation. Okay, everybody understood this two are bilinear transformation, and this is how we find. Hopefully all of you understood how to find bilinear transformation. So we'll stop here for today's session. We'll continue tomorrow again. कल हमारा आखिरी सेशन है and we'll try to discuss maximum models principle and minimum models principle in tomorrow's lecture. Okay, so tomorrow's lecture is very important, so you can actually join at 9 p.m. So we have never discussed maximum models principle and minimum models principle on YouTube. So tomorrow we are going to discuss for the first time. So you can join at 9 a.m. Okay. Thank you for joining, everybody.